Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. I'm audible, guys. Now, please confirm to me. All of you get my voice on screen. Those who are attending in online, please confirm to me. All of you get my voice on screen. Those who are attending in online, am I audible? Guys, please confirm to me. All of you get my voice on screen. Those who are attending in online, am I audible? Okay. Guys, once again, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please check it. All of you get my voice on screen. Those are attending in online. Please confirm to me, guys. All of you get my voice on screen. Those are attending in online. Am I audible? Everybody, please respond to me. All of you get my voice on screen. Those are attending in online. Am I audible? Right. Good afternoon, guys. Right, sir. Now, please check it what we completed in the last session. So, if we understand the last class content, there we started Java features, the topic there. In Java features, sorry, object-oriented features we completed. And then after that, containers in Java, the topic we started already. So if you understand these containers in Java, the content here, tell me overall how many types of containers are available in Java, or before that, first of all, tell me what is a container. Now tell me what exactly the meaning of container. Now tell me. Container is a Java element. It contains some other programming elements like variables, methods, constructors, blocks, and so on. Okay, fine. There are three types of containers in Java. What are the three types of containers in Java? First one is what there, class, abstract class, interfaces. Enum is available, but I will discuss with you later on about it, not immediately. That simple diagrammatic representation, that actual classification is what there, classes and interfaces. Again, two types of classes here we are having. First one is concrete classes and second one is what there, abstract classes. Leave this part here. So now class syntax, the class we started already. In a class, what we started there, the main purpose of the class in Java applications is to represent all the real world entities. Example for classes are like what? Employee, account, product, and so on. All these are like what their classes only. That means entities only. Entities are represented in the form of what their classes. Entities data is represented in the form of what their variables or fields. Entities behaviors are represented in the form of like what their methods. Understand it now. Then after that, some other examples we have taken there, how these methods and all the things are provided. Transaction is an entity, methods here we have taken. At the same time, transaction ID that we are able to provide. If you want to take it now, private, there we can identify private, sorry, then private, okay, then private, what we have to take there, private string transaction ID. Definitely, this is minimum transaction ID. Here we are going to take in the transaction. This we are going to provide in the form of what their variable. So this is data. Data is going to be represented in the form of what their transaction ID variable. Next one is different types of transactions. What are the different types of transactions here? Deposit or withdraw, transfer funds. All these things are like what they come under this transaction content only. Okay. Next one is a student. Student ID, student name, student address, student marks, student aggregate marks, and so on. All the things here we are getting. There we are going to provide something else like what there, aggregate marks like what this 7.2, something else. Then methods I provided, create student, search student, update student, delete student, and so on. Like this here we have taken some students now. That means some classes. All right. After that, in Java applications, everybody understand it clearly. In Java applications, to prepare classes, we have to use the following syntax. What exactly the syntax here we have to use there? The first one is what there? Access modifiers list. Next one is what there? Class. After that, class name. Class name. Then after that, extends a superclass name. After that, implements the interface list. Implements what their interface list. Then inside these classes here we are going to write variables, blocks, constructors, methods, classes, abstract classes, interfaces, enums, and so on and so on and so on. These many things here we are able to provide clearly. All right, sir, that's okay, fine. After completion of this, some observations here we are having by seeing this total content. What are the observations here we are able to get there? The first one is, all of you observe carefully. The first one is what there? For a single class, how many super classes here we can provide there? Only one super class. But how many number of interfaces we can provide there? More than one interface here we can provide. Fine. In class declaration, extends is optional, implements is also be optional. We can write a class without extends and with implements. We can write a class with extends without implements. We can write a class without both extends and implements. But if you want to write both extends and implements, first we have to write what their extends. After that, we have to write what their implements. Understand it clearly. First, we have to write what their extends. Then we have to write what their implements. That order is mandatory. Should not interchange the two elements. Okay, fine. So next one is after that access modifiers. That each and every part of the class syntax here we are understanding that part of it. Here we are going to understand like what their access modifier list. Inside these access modifiers, how many types of access modifiers are available in Java? There are two types. Two types of access modifiers are available in Java. What are the two types of access modifiers? No. The first category is what there? Scope related access modifiers. To define scope to the programming elements, we are having four types of access modifiers. What are the four types of access modifiers to define the scopes here? First one is what there? Public, protected, default, and private. See, observe carefully. These angular brackets are specified for default. What is the meaning of it clearly? Observe carefully. Default keyword is available in Java. No doubt. Default keyword is available in Java, but it is not representing default scope. It is representing some default case in a switch programming construct. Forget my point or not? It is representing what their default case in a switch, but it is not representing what their scope. It is not representing any scope here. Observe carefully. So no keyword is available to represent default scope. To represent private scope, private keyword is available. To represent protected scope, protected keyword is available. To represent public scope, public keyword is available. But similarly, to represent default scope, in general, we are thinking default keyword is available. No, but default keyword is not available. No keyword is available to represent this default scope. Okay. But without having any keyword to represent default scope, how can we represent the default scope in our programming? How can we represent the default scope in our programs there? If we come for this point, answer is very clear. Try to observe carefully. Answer is, if we declare any class or if we declare any variable without a private keyword, without a public keyword, without a protected keyword, without using these three, if we declare any variable, automatically that variable is having default scope. Understand my point? The default scope for any element inside the Java is what their default only. The default scope for every element in Java is what their default only, not any other one. Yes, all of you are getting clarity or not? So this is exactly the meaning of like what their default scope and its angular basis. Angular basis mainly representation is what there. It is not the keyword to represent default scope. Just it is a case. It is a default case for any programming element in Java. No keyword is representing this particular scope. To specify that point only, angular basis here we have used it. Okay. Right. Once again, I'm asking one question to you. Now try to answer for it. How can we represent a default scope in Java? How can we represent default scope in Java? Do you have any keyword to represent default scope? No, we don't have any keyword. But how can we declare a variable as a default? If I declare a variable without private, without protected, without public, automatically that variable is having what scope there? Default scope here. Okay, fine. See this. Now already I have given the scopes of each and every element. Private members are having scope up to the respective class. All right. Default members are having scope up to all the classes available in the current package. Then here itself, I want to give a small note. Observe carefully in the note here. To represent default scope, to represent default scope in Java applications, Java has not provided any keyword. Java has not provided any keyword. If we declare any programming element, if we declare any programming element without using the keywords like private, comma, protected, and public, then the programming element, respective programming element will have the default scope. The respective programming element will have what their default scope. Then one more point here itself, I'm telling to you another point here. The default scope for every element in Java is default only. The default scope for every element in Java is what their default only. But in some other programming languages, the default scope is a public. In some other programming languages, but in the case of Java, the default scope for every programming element is what their default only. Understand it, no? Right, sir. Now, protected members are having scope up to all the classes available in the present package and the child classes available in the other packages. Public members are having scope throughout the application in all the packages here now. That is another point here. Okay. All right. Now one more small note here I'm telling to you. Understand it clearly. All right. In Java, private scope is also be called as private scope is also be called like what there restricted scope. Yes, sir. What is that scope here? What is the name here? Other name no restricted. The most restricted scope inside the Java is what there private. Private is also be called as what there restricted scope. Right, sir. Is also called restricted scope or another word class scope or what there class scope. We can say that class scope. Class in the sense what there up to a particular class. All right. Default scope. All right. One more small note here I'm telling to you. Observe carefully. All right. In a Java, default scope in a Java default scope is also called package scope. Default scope is also called as what their package scope. That's it. In a Java, default scope is also called what their package scope. Remaining points are very same. Protected, we don't have any other particular name. Public members are having scope throughout the applications and all the packages. But some people are saying that the public is what the global. But don't say it's a global. This is wrong terminology. In general, people are coming from C++ background. They used to say it's a global. No, it is not global. Global is different. Public is different. Global is different in the sense, what is the meaning of it? No, outside of the classes also, if you declare something, no, then that will be global. But in Java, every programming element should have the scope inside the classes only. That means what I am telling you, if we declare them inside the classes, then we can define the scope. But global members in the sense, outside of the classes, we have to declare. So there's a totally different part. No need to think about it. But these are the different names. Here we are able to have about like what they're the content here, about like what they're the scopes, different names of the scopes, what we provided here now. The same thing we provided in what their diagrammatic way. The same thing here we provided in what their the diagrammatic way about this all the scopes and their content here now. That's okay, fine. Now see this part here now. Package 1, package 2, two packages here we have taken. In a package 1, class here we are having where we declared 4 variables. What are the 4 variables we declared here? First one is what there public, and next one is what there protected. Next one is what there default. Next one is what there private. Got it? What I'm telling you. So these are the like what there various scopes here what we are getting. That's okay, fine. After completion of this, another one is like what I'm telling to you. Within the same class, inside the same class, what members are available? All members are having scope within the same class. Class B, if we take now, what is the nature of the class B actually? Class B extends A. What is the meaning of it now? Class B is the child class for class K. What members are available? Except private, public, protected, default. All these members are available. Except private, public, protected, and default. These members are available. Got it or not? Next one after that. From class A to class C. Now, what is the difference between class B and class C? Both are available in the same package. But class B is what their child class of class A, but C is not the child class of what their class K. So what is the difference between the child class and non-child class? No. If class B is the child class of class A, class B can access all members of A without creating object for class K. Class B can access all members of what their class K without creating object for class K. That means available members. For example, pub variable if you want to access, yes, directly we can access inside the class B. Protected variable if we want to use, access, yes, directly we can access inside what their class B. Default member we want to access directly inside the class B, yes, we can access it directly, no problem. But if you want to access these class A members inside the class C, even though these variables are having scope inside the class C, but class C has to create object for what their class A. Then only we are able to access that A class members. Understand my point clearly? That's the difference between child class and non-child class. See, always we have to remember what is the advantage of child class no, what is the advantage we are able to get from the child classes no. The main advantage is we can access that parent class members inside the child classes without creating object for the parent class. If it is not a child class, no, we must create object for the parent class members. Understand my point clearly? Even though scope is available, but accessibility is also available. In a class B, scope is available, accessibility is available. But in class C, only scope is available, directly accessibility is not available. But to get accessibility, what we have to do there? We have to create object for the parent class K. That means class K, not parent class. We have to create object for class K. Leave it. Next one is from class A to class D. Class A to class D. If you observe this, D is a child class of class A available in different package, not in the same package. Right. Then what members are available? Public and protected. But which members are not available? Private is not available. Default is not available. Private members are strictly applicable for what there? Class A, where we declared it. Default members are available up to what there? Current package only. Understand my point here? Protected members are available up to what? Up to all the classes in the present package, and the child class is available in what there? Other packages. Yes, sir. Got it or not? Last one. Class E, if we take it now, inside this class E only, what members are available? Public members are available, other members are not going to be available. Yes, sir. Inside this class E, what members are available? No, only public members are available. We are not going to have what there other members. So what is the meaning of this particular point here? Meaning is like what there. These protected members are having scope up to all members of the present package, and the child classes in other package. That's it. Now in the non-child classes in other packages, the protected member is not available. Clear? I think so. Up to this part we completed there in the last classes. Okay, fine. That's nice. Then after this, after completion of this content here, so now we have to understand other point. What is that other point here? We have to understand it. Observe carefully. Now tell me, to represent the scope of the programming elements, to represent scopes for the programming elements, how many types of scopes are available, sir? Now tell me. Four types of scopes. What are the four types of scopes now? Come on, what are the four types of scopes now? Public, protected, default, and private. Out of all the four types of scopes, which one is the default scope for every programming element? What is the default scope for every programming element? Default. By default, which scope is available? Default scope. Understand it? That we have to remember. Definitely, somebody else may ask a question to you. Tell me what is the default scope in Java? What is the by default scope in Java? The by default scope in Java is what there? Default only. How can we represent the default scope? How can you provide the default scope in Java? If you declare any member without using private, protected, and public, automatically the scope of that particular member is what there? Default only. Right? What is the scope of the default actually? Up to the present package. What is the scope of the public throughout the application? What is the scope of the protected? Come on. Protected scope is what there throughout the current package, and the child classes in what there other packages. That's the meaning of like what there protected scope. Right, sir. So okay, fine. Whatever it may be, these are the various scopes what we are having. Now try to understand it clearly. Right, sir. Now the point is what there. Out of all these scopes, out of all the four types of scopes, which scopes are allowed for classes and which scopes are not allowed for classes? That we have to understand. Let's see in the point of programming here. Everybody understand it clearly. Let's see programming here in the point of this. Let me remove this, even not required. Now I want to create project apps. Okay, whatever it may be. Tester.java is available. In a tester.java, what I want to take there, class test, for example. Inside the class test, main method is available. Inside the main method, just I want to write something else. System dot println of just class syntax. Class syntax checking something else. Just like this here, I want to write class syntax checking. That's it. That's the message here I'm trying to provide. Huh. Now here, my requirement is what there. What exactly the access modifiers are allowed by this class. First of all, let me declare my class as a private. I declare class test as what there private. Then immediately I want to open my right so now command kit, that means terminal. Inside the terminal, I want to check it Java C space tester.java. Let me check this. Now we are getting some error. Please check this error, sir. What is the error here we are getting there? Now tell me. Modifier private not allowed here. And before that, one more point I want to give confirmation from this total patch here. Public, protected, default, or private. In general, these are called access specifiers as per the other programming languages information. But in Java, private, protected, default, and public are access modifiers. We don't have any concept like access specifiers in Java. Only the concept is what there access modifiers in Java. Please remember it. That's clear? Fine. Now the point is what there private. If I declare a class as a private, immediately we are getting an error. What is the error we are getting there? Modifier private not allowed here. So what is the meaning of it now? Private is allowed or not allowed here? Not allowed. Please remember this conclusion. Okay, fine. After that, I have not provided anything. No private, no public, no protected. Then what is the scope of the class test? Come on, what is the scope here? Default scope. Am I right or not? Default scope here we are getting it. Now let me check this default scope here. Is the default scope is possible or not? Java C space tester.java. Have you got any compilation error? No compilation error here. We are not getting any compilation error. No compilation error in the sense. Now tell me, public, that means default is allowed or not allowed? Yes, is allowed. Of course, if we run this program, there we are able to get output like what there? Class syntax checking. It's okay. No compilation error. Now it is allowed. So up to now two scopes here we checked private and default. Private is not allowed, but default is allowed. That's nice. Next one is after that, I want to provide like what there protected. I want to provide like what there protected scope here I want to provide. All right, now let me check this here. Protected scope is allowed or not. Now Java C space tested.java. Any error here? Have we got any error? Yes, we got some error. What is that error now? Tell me. Modifier protected not allowed here. Modifier protected not allowed here. So this is exactly the meaning of what there. This compilation error. Modifier protected not allowed here. That's okay, fine. Okay. Next one. The remaining part is what there? Public. The remaining part is what there? Public. Let us check this clearly. Now Java C space tested.java. Have you got any compilation error? No compilation error here we are getting. No compilation error. Java space test. There we are getting class syntax checking. Output here we are getting. Now tell me. So now we are getting clear cut awareness here. Now we are getting the clarity. What clarity here we are getting there? Now tell me. So now in a class syntax, what access modifiers are allowed and what access modifiers are not allowed? If you observe this, public is allowed, protected is not allowed, default is allowed, private is not allowed. Right. From the above list of access modifiers, from the above list of access modifiers, Java classes are able to allow only public and what next one here no default in the class syntax in its syntax. Right, so only these two are allowed. Okay. Only these two are allowed. Private and protected are not allowed in the class syntax. They are not allowed in what their class syntax. One more small point to all of you, or try to understand it clearly. So classes are able to allow only what? Public and default. Classes are not allowing what? Private and protected. Remember this conclusion here we have to remember. All right, then after that, one more time. Now let me check this content here. I think so it is not required. Right, sir. Now observe carefully. Okay, now this is a test class here I have taken. That's okay, no issues. For example, I want to take what there class A, some other class here I have taken. This is totally what there outer class, other class. Then inside this class K, I want to take what there class B. Inside this class K, I have taken what there class B. Observe carefully. First of all, tell me, is it possible to write a class inside a class? Is it possible to write a class inside another class? Possible or not possible? Definitely it is possible. It is possible to write a class inside what there? Another class. So that internal class is called what there? Nested class. Internal class is called what there? Nested class or inner class. Inner class or nested class. Clear? After this, after completion of this, now tell me, I checked for outer class now. I checked for this outer class. Test is an outer class that I checked here. Public is allowed, default is allowed, private and protected are not allowed. Now I'm going to check for the nested class. I'm going to check for what their nested class or inner class. For each and every access modifier, I want to check it. First of all, let me check it. What I declared, sir? The nested class, what I declared here, no? Public. Is that public is allowed or not? Now let me check this one. Java C space tester.java. Have you got any compilation error? No compilation error. Java space tester. Now here we are getting what their output. Class syntax checking. Output here we are getting. That's okay. Public is allowed for what their inner classes. Next one is I want to provide like what their protected. Protected here I declared here. Now try to understand it clearly. Now Java C space tester.java. Have got any compilation error? No compilation error. Please recognize this. Outer class are not allowed with what they're protected, but inner class is allowed with what they're protected. Protected is allowed for inner classes, but protected is not allowed for what they're outer classes. The conclusion here we have to understand. For outer classes, protected is not allowed. For inner classes, protected is allowed here. Now that's the proof here what I'm telling you. Similarly, now leave this one here. Now here we are not getting any compilation, that means compilation error. There if we execute it, there we are getting output like what there? Class syntax checking. It's okay, fine. Now for the inner classes, nothing I provided. No access modifier I've used to represent the scope. So by default, what scope is available for class B? Come on, what scope is available by default? Default scope is available, right? Now let me check this. The default scope is possible or not possible for this particular one. Java C space test.java. Now tell me, what is the situation here now? Successful or not successful now? Successful here now, right? No problem. No error here we are getting. Output here we are getting. Default is also allowed. Last one. What is that last one here now? Tell me. Private. Private is allowed or not allowed here? That I want to check now. Now understand it clearly. Java C space test.java. Tell me, have you got any compilation error? No compilation error. That means for the inner classes, almost all the access modifiers are allowed or not. For the inner classes, public, protected, default, and private, all four access modifiers are allowed or not. Right, sir. All access modifiers are allowed for what their inner classes. That we have to understand. Right, sir. Now see this point here. From the above list of access modifiers, Java classes are able to allow only public and default in its syntax, but private and protected are not allowed in the class syntax. Then immediately I'm giving one more note here, one small note here. In the case of inner classes, all the access modifiers like public, protected, then what next one here? Default and private are allowed. In the case of inner classes, all the access modifiers like public, protected, default, and private are allowed. Right. Now this is what exactly the point here we have to understand clearly now. But I have a question. Everybody must understand the answer for this question here. I have a question now. What exactly my question here in this case now? Anyway, question is very clear. Try to understand it now. Right, sir. Private and protected. Private and protected access modifiers are not allowed in the outer classes. But how inner classes are able to allow the private and protected access modifiers. Right, sir. Now this is the question here what we are having. Now try to understand it. Private and protected access modifiers are not allowed in the outer classes, but how our inner classes are able to allow the private and protected access modifiers. Right, sir. Now I'm going to give some reasons to you. Now try to understand it clearly. Just you have to apply a simple common sense, not like any other one. Simple common sense. Observe carefully. This is our entire class. Myself, I'm representing this class. You are the members of the class. Who is the head of the class? Myself is the head of the class. You are the members of this class. Yes, sir. All of you are getting it or not? This is actual representation. Think of me as a class. You're all what there members of the class. Myself is a class. Simply we can understand your variables and methods. Got it? Understood this comparison here, no? Myself is what there class and you are what there variables and methods. Like this you can understand. For example, today at the end of the class, I'm going to give an announcement like what? Tomorrow onwards, everybody must wear tuck and tie or tuck and shoes. For example, not serious, right? Don't wear tuck and shoe and tomorrow onwards. Example, understand it. If I make a condition like this, if I give this condition like this, now tell me who are going to follow the same thing tomorrow onwards? Who are going to follow this rule from tomorrow onwards? That means every member of the class must follow this rule or not. Understand my point here? I made this rule, so every member of the class must follow this rule or not. That means you are the people, you must follow this rule, right? But that is not applicable to me. Think in this way. Here only we have to apply our common sense. I made this rule, but I'm not going to follow it, but you have to follow it. Do you expect the same rule from me? No, I'm not a member of the class. I'm a class. I'm the head of the class. I'm a class. So I will not follow it, but I will create the rule. You have to follow that rule, but that is not applicable to me, but that is applicable to every member of the class. First of all, tell me, have you understood this point? Are you understanding up to now? Now, listen to my next technical point. So you'll understand effectively the point here. My next technical point is what? Listen carefully. If any scope is defined on the basis of the class or on the origin of the class or on the scope of the class, if any access modifier is defined on the origin of the class or on the basis of the class or on the boundaries of the class, then that access modifier is not applicable to the classes, then it is applicable for the members of the classes including inner class. Why? Because inner class is a member of the class. Come again, what is the point here? I said, if any access modifier defined on the origin of the classes or on the basis of the classes or on the boundaries of the classes, then it is not applicable for the classes. It is applicable for what? Their members of the classes, including inner classes. Why? Because inner class is a member of the class. All right. Now let's move on to the private scope. For example, if I ask a question to you, class A I have taken. Everybody put more concentration. Inside this class A, int I is equal to 10. I'm going to declare I variable as a private, for example. Now, if I ask a question to you, what is the scope of the I variable? Come on, what is the scope of the I variable? We can say that the scope of the I variable is what? They're private. Okay, the private in the sense, what is that region? What is that visibility area? That I variable is available up to what there? Class K. That I variable is having scope up to what there? Class K. Up to class A only. In outside of the class, I variable is not visible. The scope of the I variable is what there? A. Up to class K. Yes, sir. Clear or not? Okay. Let's understand the point here. So private is an access modifier. It is defined on the boundaries of the class or not? The private scope is defined on the boundaries of the class or not? Come on, understand my point here now. So I variable I declared private. Now tell me, because of this private keyword, what is the boundary for I? The scope of the I is what there? Class boundary. How long the class is available? Up to that only that I variable is available. That means private keyword is defined on the boundary of the class or not? Come on. Private keyword is defined on the scope of the class or not, on the boundary of the class or not. So that private is not applicable for class. Private is applicable for what? Their members of the class. Right, sir. Private is not applicable for what? Their class. Private is applicable for what? Their members of the class. Why? Because the private access modifier is defined on the boundary of the class, on the origin of the class, on the boundaries of the class, on the scope of the class only. Say, for example, okay, leave it. Now tell me, if I declare I variable is a private, then we can say that the I variable is a member of the class, so it is available up to class A. Okay, there is a meaning for it. For example, if I declare class A as a private, now tell me what is the scope of the class A? Private I declare, no. The scope of the class A is what? Now tell me. The class A is available up to what? Do you have any container for class A? No container is available. So is there any meaning to specify private scope for class A? Come on, think in this way. Is there any meaning for declaring a class A as a private? Is there any meaning for it? Or even if you declare that, will you define any scope for class A now on the basis of this private? It's totally meaningless or not? Yeah, because of that reason, what's the point I'm telling there? Private access modifier is defined on the boundary of the class. So it will not be applied for what the classes, it will be applied for what their members of the classes. I variable is a member of the class A. So if you declare that I variable as a private, then it has the scope up to class A. Has I got it or not? Okay, fine. Leave this one. So the scope of the private is what there up to the current class. So up to the current class in the sense we are using boundaries of the class to define the scope of the private variable. Right, sir. To define the scope of the private, we have used class boundary. So because of that reason, it is not applicable for what their classes. It is applicable for what their members of the classes. Got it or not? Right. Now let's move on to the protected. Tell me in general, what is the scope of the protected? Protected scope is what? Now tell me in general, what is the scope of the protected? Protected members are having scope throughout the present package and child class. And what their child class? Again, we are bringing the class scope in protected or not? Again, we are bringing class scope in the protected keyword or not? So that means protected keyword is also be defined on the origin of what their classes. So we cannot apply it for what their classes. We can apply it for what their members of the classes. Got or not? So okay, now similarly, now tell me public scope. What is the scope of the public? Now tell me. Public scope is what there throughout the application. Is it defined on the basis of this classes origin? No, it is not defined on the basis of what their classes can. So we can apply it, no problem. Now tell me, default scope is available. What is the default scope now? Tell me, up to the present package. Is it defined on the base of classes? No, the default is not defined on the base of what their classes. It is defined on the base of what their packages. No, so we can apply it for what their classes here. No, yes, sir. Got it or not? Okay. Finally, the point is what there. If any access modifier is defined on the origin of the classes, then it is not applicable for classes, then it is applicable for what their members of the classes. Right, sir. Now let me conclude that point here. Then after that, I'll move on to some other content here. Right, sir. Now observe carefully. If any access modifier is defined on the origin of the classes, then that access modifiers are not applicable for the classes. They are applicable for the members of the classes, including inner classes. Why? Because what is the reason for it? Inner class is a member of a particular outer class. Inner class is a member of a particular outer class. Right, so try to understand it clearly. That explanation here I'm giving to you some other punch here. Now observe carefully. The access modifier private is having the class scope. Am I right? The access modifier private is having what their class scope. So it is defined. So it is defined on the origin of the classes. So it is not applicable. It is not applicable for the classes. It is applicable for the members of the classes. Including inner class. That's it. All of you get my point here. So the access modifier private has the class scope. Has the class scope in the sense, what is the meaning of it now? Throughout the class, up to the present class. Has the class scope inside the bracket, what I am telling there, up to the present class. Just for our clarity purpose, I am giving there up to the present class. Okay. So it is defined on the origin of the classes. So it is not applicable for the classes. It is applicable for what there? For the members of the classes, including inner class. Don't worry. Then syntax wise, I'm going to show each and every point once the total class syntax is completed. There are almost all 15 to 20 syntaxes I'm going to write at a time. Which things are valid and which things are invalid. To provide that information, I'm going to prepare almost like what there 15 to 20 syntaxes there on the basis of these classes. By that we are able to get the total clarity. But time being, we have to understand why private is not applicable for outer classes, why private is applicable for what their inner classes. That's the point here I've given there. Okay, fine. Next one is another point here I'm telling to you. Observe carefully. The access modifier protected has the scope up to the present package and the child classes in the other packages. Right, sir? The access modifier protected has a scope up to the present package and the child classes in the other packages. So here the protected access modifier defined on the origin of the classes. Again, protected access modifier is defined on the origin of the classes. So it is not applicable. It is not applicable for the classes. It is applicable for the members of the classes. Like what they're like. Okay, including inner classes. That's it. So this is the another point here we have to understand clearly. So finally, we have the question: why private and protected are not allowed for outer classes and why are these allowed for the inner classes? The reason is very clear. The access modifiers private and protected are defined on the origin of the classes. So they're not applicable for classes, but they're applicable for what they're members of the classes, including what? Inner classes. Yes, sir. Clear? Fine. These are the points here. What you have to recognize. Okay, fine. Leave this content here. After that, after completion of this, by this, what we completed totally, the scope related access modifiers description, just we completed. Scope related access modifiers description, here we completed. Yes, sir. All of you are getting it or not? Okay, fine. Their syntaxes I will provide, at a total, all syntaxes I'm going to provide at a time after completion of the total classes concept. Okay, fine. Leave this part here. So the second one is what? After completion of this, the next one is like what we are going to understand. To define some extra nature to the programming elements, we will use the following access modifiers. What exactly the access modifiers here we are going to use to define some extra nature to the programming elements? No, all of you observe carefully. First one is what there, right? So now static, final, abstract, then after this native, volatile, then after this synchronized, transient, after this strict FP, and so on, if anything is available. So these are like what there, second list of access modifiers that we can understand. Static, final, abstract, native, volatile, synchronized, transient, strict FP, and so on. These are the second list of access modifiers. These are mainly for the sake of what there, to define some extra nature to the programming elements. I want to get some clarity. What exactly the meaning of extra nature? What you are understanding about the extra nature? What do we understand about that extra nature? I will give some examples to try to understand it clearly. Understanding. First of all, understand the concept. Then after that, I'll move on to the content. What is that extra nature actually? Listen carefully. Say for example, class A, I declared. Inside this class A, int I is equal to 10. For example, int I is equal to 10. My requirement is what? I want to access I variable in outside of class K. Say for example, I have main class test. Inside this main class, I'm going to have public static void main string array aux. Then inside this, now I want to access I variable. In general, by default, the concept is what? In general, the topic is what? The fundamental is what there? If you want to access the members of any particular class, we must create object for the respective class. Then where reference variable is going to be generated, we must use that reference variable. That's it. That is it by default. That is minimum fundamental concept. Now tell me, what is the fundamental concept? If you want to access the members of any particular class, first we have to create object for that class where reference variable will be generated. By using that reference variable only, we have to access the respective member. Say for example, a small a is equal to new a. Is that what we provided? A small a is equal to new a, object I created, where what is the reference variable? A is the reference variable. By using that reference variable only, here we are able to access the respective variable a dot I. A dot I. Is it? All of you are getting it now? So we have to create object for class K. After creating object for class K, by using reference variable only, we are able to access the respective class members. This is the fundamental concept in Java. This is by default concept inside the Java. Clear to all of you? All of you are getting clarity up to now? Okay. All right. Now let's move to the point here. For example, I declared int j is equal to 20. Almost all same as I variable only, but 20 is a value for j variable. How can we access the j variable? How can we access the J variable inside the main class? Now tell me, by using the same reference variable, we can access it or not? One time if we create object for class K, we can access all members of class K by using the same reference variable. Now, how we are going to access it now? System.out.println. System.out.println, for what purpose we are using there now? To display concept, to display some data on command prompt. To display the data on command prompt, we are using what there? System.out.println. There we are going to use what there? A.j. Am I right or not? Fine. Observe carefully. For example, if I declare J variable is a static, access modifier I provided static, through this static we are giving some extra nature to the J variable. Through this J variable we provided what there? One extra nature. What is that extra nature? Up to now, members of the class A we access it by using reference variable or not? Because of the static keyword, along with the reference variable, we can use class name also to access the static variables. To access the variable, we can use what there? Class name also, along with reference variable. That is extra we provided because of what keyword? No, static keyword. Got my point here? Now I am telling to you, observe carefully here. System.out.println of capital A dot J as it is possible. Now tell me, J variable we can access in two ways. What are the two ways? Now tell me. One is by using what there? A reference variable, and second one is what there? By using class name. Why? Why class name is possible? How it is possible for J to access by using class name? Why? Because by using what keyword? No, static keyword. Now tell me. You only tell me. Is it possible to access system.out.println of A dot I can access like this? Is it possible to access I variable by using class name? No, not possible. Why it is not possible? That I variable is not a static variable. If it is not static variable, how can we access that I variable? How do we access that I variable if it is not static? Then definitely we have to use what there? Reference variable only. So now here we are getting an error. But here in this case we are not getting any error. Now here also we are not getting what there? Error. Now tell me, static keyword is providing some extra functionality or not? Static keyword is giving some extra nature to the variable or not? What is that extra nature here we are getting there? In general, we are able to access variables by using reference variable of the respective class. But by declaring a variable as a static, we can access that variable by using what there? Class name also, along with what variable? Reference variable. Along with the reference variable, we can access, we can use what there? Class name also. All of you are getting it or not? Right, sir. Now, this is exactly the meaning of what their static keyword. Like this, final variables are having one nature. Abstract keyword is having some other nature, is providing some other nature. Native is providing some other nature. Volatile is providing some other nature. Like this, each and every access modifier is providing a particular, a new, some extra nature to the programming elements. Just have taken example for static now. Similarly, we can understand each and every access modifier of the second list is able to provide some extra nature to the programming elements. Are you clear about these points now? All right, sir. That's okay, fine. This is the meaning of like what their extra nature. To define the extra nature, we are using all the access modifiers. Just this is knowledge purpose only. What I given here. Just leave this one, not required here. Okay, fine. And one more point I'm telling there, at this level not required to understand the purpose of each and every access modifier. They're available throughout the Java. They spread it throughout the Java. They're not at a single position. They're not available at present immediately. They're available throughout the Java. So we are going to understand that each and every access modifier by moving on to the concepts in the future, but not immediately. But what we have to understand at this level, we are discussing about the class syntax. In that class syntax, what we have to understand at this level here, we have to understand out of these all access modifiers, which access modifiers are allowed for classes, which access modifiers are not allowed for classes. Up to that only we are going to understand. The remaining, the functionalities of each and every access modifier is not at all required immediately. Yes, sir. All of you are following or not? Now, just I want to check it. What access modifiers are allowed for classes and what access modifiers are not allowed for classes, that we are going to understand clearly. Now, let's see this one. All of you observe carefully. Now, I'm going to check for the content here. Now, just I want to remove this part here, not required. Now just class K, here we have taken there for the classes, what access modifiers are allowed, what are not allowed, that I want to check. First of all, let us check this clearly. Static class, here I created. What I created here? Static class. Now let me check it now. Java C space test.java. Any error? 1 minute. Java C space test.java. Just now we are getting error. That I am expecting. Right, sir. Now please check this. What is that error here we are getting there? Previously, without saving the program, I compiled the program. That's why no error we got there. Now I saved it, I compiled it. Now tell me, what we are getting there? Modifier static, not allowed here. For the classes, static is not allowed. Please remember this. Next one is after this, final. Yes, final classes is an official topic in Java. Final classes is what there is an official concept inside the Java. So then it should allow actually. Now let me check this. Java C space tester.java. Allowed or not allowed here? No compilation error. That's sufficient. Now it is allowed. If you are getting compilation error, then it is not allowed. Otherwise, it should be allowed here. Now observe carefully. Now we are getting output. That's okay, fine. Allowed. Final is allowed. Okay. After this final, abstract class. Abstract is allowed or not allowed? Definitely it is allowed here. Abstract class. Three types of containers mainly. What are the three types of containers? Now tell me. First one is what there? Class. Next one is what there? Abstract class. Next one is what there? Interface. No. So definitely it must be allowed. It must be allowed. Now let me check this one. Java C space test.java. There's no compilation error. Directly we are able to get some output. Abstract is allowed. That's okay, fine. After this abstract here, next one is what there? Native. Observe carefully. In Java, native methods are available, but not native classes. In Java, what methods are available? Native methods are available, but not what their native classes. Understand it now. Now, here we have to understand Java C space test.java. Error we are getting. What is that error here? Modifier native not allowed here. Yes, sir. Have you remembered it? Up to now, what are allowed or what are not allowed? Have you understand it now? Now tell me, static is allowed or not allowed? Not allowed. Final is allowed or not allowed? Yes, final is allowed. Abstract is allowed or not allowed? Yes, allowed. Next one is native is allowed or not allowed? Not allowed. Leave this one. Next one is what there? After this, volatile. In Java, understand it clearly. Volatile variables are possible, but not volatile classes. In Java, what are possible? They know volatile variables are possible, but not like what their classes can. Understand it clearly. Java C space tester.java. Now here we are getting an error. Modifier volatile not allowed here. Leave this one. After this, after completion of this, next one is synchronized. In Java, synchronized in Java, right, sir. Okay. In Java, synchronized methods are possible, but not synchronized classes. Synchronized methods are possible in Java, but not what they're synchronized classes. Now try to check this one. There we are getting error here. Now we are going to get what there? Compilation error. Observe carefully. Java C space test.java. Right, so now we are getting compilation error. Modifier synchronized, not allowed here. Leave this one. Synchronized is okay, fine. Next one is what there? Transient. Transient. All of you understand it, no? Transient. Then what is going to be available? Observe carefully. In Java, transient variables are possible, but not transient classes. Transient classes are not possible. Only transient variables are possible. So here we are going to get compilation error. Java C space tester.java. Now here we are getting modified transient, not allowed here. Leave this one. After that, the last one is like what there? Strict FP. Observe carefully. In Java, strict FP is possible for variables, for methods, and even for what their classes. Got my point or not? But using this strict FP is deprecated, means that outdated. Then you may get a warning message max, but not error. I get my point or not? You may get what their warning message, but not like what their error here. But let's understand it clearly. What we are able to get now. Java C space tested or Java. Now here we are getting what's that message, sir? Now tell me. Warning message, but not what there error. Observe carefully. What is the term? What is the error here? Strict FE as of release 17. All floating point expressions are evaluated strictly, and strict FE is not required. By default, we are following the same strict FE principle. So no need to use strict FE explicitly. As of what version of the Java? 17. At present, I'm using what version of the Java? 17th version here. That's why we are getting this warning message, but it is not error. Please remember it. Error is different. Warning message is different. Warning message is an alert message. Understand it now. But error is what there? You violated the condition. That's why error we are getting. But even though we violated, but still that is acceptable. That is like what there? Warning message here. So just it is warning message. It is not like what there? Any error. So the point is what there? Now tell me, is it allowed or not allowed here now? Yes, allowed. No problem here now. Now observe carefully. All of you know how many things are allowed up to now, how many things are not allowed here, if you understand it. Now let us take the case here. Let us understand the point here. All right. From the above list of access modifiers, from the above list of access modifiers, from the above list of access modifiers, classes are able to allow like what there. Now tell me, final, comma, abstract. Now tell me what next one. Final, abstract. Apart from this, native is not allowed, volatile is not allowed, synchronize is not allowed, transient is not allowed, and what next one here? No, strict FP. And all the remaining access modifiers are not allowed. All the remaining access modifiers are not allowed in the classes syntax. Classes syntax. Let all of you know. Just remember this, only three access modifiers for the class syntax. What are the three access modifiers? No, final, abstract, and what next one? No, strict FP. All the remaining access modifiers are not at all allowed. Okay, fine. Outer classes here we checked, sir. That's okay, fine. But inner classes here I want to check. For inner class also here I want to check where a small conclusion is available. For the sake of that conclusion, I want to check for what their inner classes. Now let us check, let us think about it. Now understand it clearly. Right, sir. I want to remove this one here. I want to take this class K. Inside this class K, I am going to take class B. Clear? Class B. Now all of you understand it. For outer classes, static keyword is allowed or not allowed? For outer classes, static keyword is allowed or not allowed? Not allowed. Already we have seen that. Now for inner classes, I am checking now. Inner classes, static keyword is allowed or not? Now let me check this one. I want to compile it. Java C space tested.java. No compilation error. No compilation error in the sense what they allowed. But previously, the static keyword when applied for outer classes, we got compilation error. The access modifier static not allowed here. Like this, we got some compilation error. But now we are not getting any compilation error. Try to understand it now. So static keyword is allowed for what there? For the inner classes, but it is not allowed for what there? Outer classes here. Please remember this punch here. Next one is after that. Okay, fine. Static is okay. Next one is what there? Final is allowed for outer classes. Am I right or not? But what about for this inner classes here? We have to check no. Java C space tested.java. Any compilation error? No compilation error. Now it is allowed. Final is okay, fine, no problem. Next one is what there? Abstract. Now you only tell me, is it possible to declare an abstract class inside a class here? Inside a class? Abstract class inside class. Is it possible or not possible? As previously I said to you, yes, okay, it's possible. All are possible. Combinations no. We can declare a class, abstract class, and interface inside a class. We can declare a class, abstract class, interface in what there? In abstract class. We can declare a class, abstract class, interface in what there? In interface. We can declare all in what there? Classes inside the abstract classes and inside what there? Interface now. So what this is an example for what? This is an example for what? Abstract classes in what there? Classes. We can declare an abstract class inside what there? Inside a class. We can declare an abstract class inside what there? Class. Sir, following or not? Right, sir. Now let me check this. Error, no error. Now easily we can identify this. Java C space tested.java. No compilation error here we are getting. So it's possible here. Leave this one. Abstract class is okay, fine. Then after this, after completion of which native. You know already native is not for the sake of like what their classes, it's for the sake of only what their methods. So definitely here we are able to get what their compilation error. What is that compilation error? Now tell me. Modifier native not allowed here. Okay, fine. Leave this one. Native is not allowed. Next one is what there volatile. Volatile is applicable for only what there is applicable for only variables, not for what their classes can. So definitely here we are able to get what there compilation error. Java C space tester.java modifier volatile not allowed here. That we are getting there. It's okay, fine. Leave this one. After this volatile, then what next one can now tell me? Synchronized. Synchronized is applicable for methods only, but not for classes. Again, we are able to get what the compilation error. Java C space tester.java. Here we are getting modifier synchronized, not allowed here. Leave this one. After completion of this synchronized, then what next one here? No, transient. The transient is applicable for variables only, not for the classes. There we are able to get what their compilation error. Java C space tester.java modifier transient not allowed here. Just leave this one. Next one is what there. After this, strict FP. We know already this point here. Strict FP is allowed for the inner classes, but we are able to get what? Warning message here we are able to get. What we are able to get there? Warning message here we are able to get. Now let me check this. Java C space what next one? Tester.java. Now here we are getting warning message, but it is allowed clearly. Now tell me, sir, out of all these things, what are allowed for the inner classes, what are not allowed for inner classes? Now tell me. From the above list of access modifiers, inner classes are able to allow what access modifiers? Now tell me. Static, final, abstract, and what next one here? No, strict FP. But all the remaining access modifiers are not allowed in what their inner classes. Got it clearly? All of you are understanding this point now? Overall, access modifiers and their types, and which access modifiers are allowed and which access modifiers are not allowed inside the classes and inside the inner classes. These concepts here we understood clearly. That's clear? All of you are getting my point now? Leave this one. If you observe one time the class syntax, up to now, only this part is completed. The entire class syntax, just we completed only what there, this particular access modifier list. Now tell me, what is the next one here? The next one is what there? Class keyword. Right, sir. Simple statement. First of all, tell me how many number of object-oriented features are available? 7 number of object-oriented features. What are the 7 number of object-oriented features? Class, object, encapsulation, abstraction, inheritance, polymorphism, message passing. Good. These are common object-oriented features for the programming languages. C++ is having the same object-oriented features. Java is having the same object-oriented features. Python is having the same object-oriented features. Like this, programming languages have to represent these object-oriented features. Then the programming languages are object-oriented programming languages. Is that got my point or not? Object-oriented features are different. Programming languages are different. If any programming language is representing these object-oriented features, automatically that programming language is what? Is an object-oriented programming language. So, if you want to say Java is an object-oriented programming language, Java must represent all features of the object-oriented programming languages or not? Java must represent all features of the object orientation or not? Means that Java must represent classes, Java must represent object, Java must represent encapsulation, abstraction, inheritance, polymorphism, and message passing. Then only Java is what there? An object-oriented programming language. As part of representing all the object-oriented features, Java must represent class object-oriented feature. To represent class object-oriented feature, Java has provided a special keyword. To represent a class object-oriented feature, Java has provided a special keyword. That special keyword which is provided by Java to represent object oriented feature class. That is what their class keyword. Is it? That is what their class keyword, not more than that. That's it. Now try to understand the point clear, what I'm telling to you. That's it. Observe carefully. Class is a Java keyword. Class is a Java keyword. Everybody understand it clearly. Class is what there? A Java keyword. Clear. It is able to represent. It is able to represent the object-oriented feature class. It is able to represent the object-oriented feature class. That's it. Class is a Java keyword. It is able to represent the object-oriented feature class. Next, one more point here. In Java applications, to declare the classes, we must use the class keyword. We must use the what? Class keyword. Without using class keyword, we are unable to declare classes. To declare the classes, we must use what there? Class keyword. Okay. Right. Next one is what? After this, after class keyword. What next one here? This is simple point that we completed. What is this next one, sir? Now tell me. Class name. The next one is what there? Class name. Nothing. Class name is a name to the class. Means that it is an identifier to the class. Class name is what there? Is an identity for the class. In order to recognize that class, in order to create object for the respective class, we require some identity. We require some name. That's why name is provided for the classes in the form of what there? Class name. Observe carefully. Where class name, where the class name is an identifier for the class in order to recognize and access the class, in order to recognize and access the class in Java applications. That's it. Okay. Right, sir. Now just I want to stop the points up to now. Whatever the points here we complete up to now, just I want to stop here regarding this class syntax. In the class syntax, what topics are remaining actually? Just in the syntax of the class, what exactly the points are remaining? Up to this part we completed in today. The remaining content is what there? Extends, and what next one? No, implements. There we are going to understand the content. Once we completed these two, extends and implements also, after that I'll give a list of syntaxes which are valid and which are invalid about the classes declaration. By that we are able to get some clarity. After that I'll start to go for what there steps to prepare, that means steps to use classes in Java programming. How to declare classes, how to access the members of the classes, what exactly the steps here we have to follow to prepare classes, to utilize classes in Java programming. By that we are able to get some clarity on this particular content. Yes, sir. Clear to all of you now? Right, sir. Now just to take few minutes break, I want to stop this object orientation here. Right, sir. Tomorrow, actually as per the schedule, I need to take the class now. Just give tomorrow is a gap now. I was not feeling well. So tomorrow, just give gap on tomorrow. Day after tomorrow onwards. In the next Sunday, definitely we'll plan for the classes now. As per the schedule, tomorrow we have sessions, at least 2 hours of class I'm planning there. But yesterday onwards, I don't want to take the class there, no problem. Then tomorrow just gap for you, for all of you. Next Sunday, definitely I'm going to take the class for you regarding this object orientation. Okay, right, sir. Right, take few minutes break and come back. I'll start first application development. Thank you. So guys, just try to use the same link for the first application development here. Just use the same link, guys, for the first application development. Okay, right. Thank you.